Hey, what's going on, guys? Let's do this problem right here. Here the first question is asking an enclosed chamber with sound absorbing walls has a 2 times 1 meter square. So this is going to be area 2 times 1 and opening for an outside window. A loudspeaker is located outdoors 75 meters away and facing the window. The intensity level of the sound entering the window space from the loudspeaker is 80 decibel. So they already given the intensity that's entering the window. So we don't have to use 4 pi r square. 4 pi r square is basically when we have this intensity from a distance, then we have to use 4 pi r square to calculate which intensity is reaching. Now here they already given the intensity entering the window in decibels, so we don't have to use 4 pi r square. So this information is not necessary. Now let's go ahead and read the rest of the problem. Assume the acoustic output of the loudspeaker is uniform in all directions and the acoustic energy incident upon the ground is completely absorbed and therefore is not reflected into the window. The threshold of hearing is this. The acoustic power entering through the window space is what? So to calculate the power, we have to use this equation. We know that intensity is equal to power over area. So power is going to be intensity times area. Now in order to do this problem, we have to have intensity in terms of watts. This is in decibel, right? To convert decibel into watts, we use this equation. Beta is equivalent to 10 log I over I naught. Now let's go ahead and plug the values. This is 80 decibel. So 80 decibel is equivalent to 10 log I over I naught. And if you divide both sides by 10, this is going to be 8 and the other side we are going to have 1. So this is going to be simply 8 is equal to log I over I naught. Now to get rid of this log, we have to take power, 10 power. So if you take 10 power 8, in the other side we are going to have I over I naught, because 10 power and log cancels, we are going to have I over I naught. Now I is going to become I naught times 10 power 8. I naught is 10 to the power of minus 12, because 1 times 10 to the power of minus 12 is same as 10 to the power of minus 12. So this is going to be 10 to the power of minus 12 times 10 to the power of 8, and that's going to give us 10 to the power of minus 4. And this is watts per meter square. Now we have the intensity in terms of watts, watts per meter square. This intensity is same as 80 decibel. We just convert this decibel into watts per meter square, right? So this and this are same thing. Now here we have I times A. So all we have to do is just plug the values. 10 power minus 4 watts per meter square times this 2 times 1, that's going to be 2 meter square. So this is going to be just 2. That's our area. Now this is 2 times 10 to the power of minus 4. Here if you notice, the answers are given in microwatts. To get this one in microwatts, we have to have power 10 to the power of minus 6. So all we have to do is add 2 0, and that's going to make this one 10 to the power of minus 6. So this is going to be 200 microwatts, because if you put 2 zeros right here, this is going to be 10 to the power of minus 6. 10 to the power of minus 6 basically micro. So this is going to be 200 microwatts. So this is going to be E. The answer is C. Now let's look at the next problem. A certain crying baby emits sound with an intensity of 8 times 10 to the power of 8 watts per meter square. What is the intensity level due to a set of 5 such crying babies, all crying with the same intensity? You can neglect any absorption, reflection or interference of the sound. The lowest detectable intensity is this one. So here they are asking for the intensity. What is the intensity level due to these crying babies? And the answers are given in decibel. So here we have to use this same equation again. Beta is equal to 10 log I over I naught. Okay, let's get rid of this part right here. Okay, so here we have to use the same equation, that is beta 10 log I over I naught, right? Here beta is going to be this one in decibels. That's what we are trying to find, right? So this value is for one crying baby, and they are saying 5 crying babies, so what's going to be the value? That's the question. So if this is 5 crying babies, what we have to do is 10 log 5 times, this is for 1, right? 1 is 8 times 10 to the power minus 8, and in the bottom we are going to have this basic 1 times 10 to the power minus 12, that is threshold of hearing. That's going to be always this value. So this is going to be 1 times 10 to the power of minus 12, and all we have to do is just plug it in the calculator, right? So you will get 10 log 40 times 10 to the power of 4, and if you calculate that one, you should get 56 decibel. Now let's look at the next question. If the intensity level at distance d of one trombone is 70 decibel, what is the intensity level of 100 identical trombones all at distance d? Again, this is the same type of equation, same type of question. All you have to do is find this one in terms of watts per meter square, then multiply by 100, and then convert this one back again into decibel. The easiest way to convert a decibel into watts per meter square is this. This is our threshold of hearing. This is always going to be the same. I naught value, it's always 1 times 10 to the power minus 12. And if you remember this, all we have to do is whenever they give you a decibel like 70, 80 or whatever, all you have to do is just take the first value, 7. Here this is 7, right? And if you add this to the power 10 to the power minus 12, that's going to be this decibel in watts per meter square. This is going to be true for any situation. Now, if you add 7 to this one, what will you get? 10 to the power of minus 5, right? Because 7 minus 12, that's going to give you 10 to the power of minus 5. So this one in watts per meter square is going to be 1 times 10 to the power of minus 5. Let's write it in different color. So 1 times 10 to the power of minus 5 watts per meter square. So this is this one in watts per meter square. Now if this is 100 identical trombones, what you have to do is you have to multiply this one by 100. If you multiply this one by 100, you will get 10 to the power of minus 3, right? Watts per meter square. Now to convert this one into decibel, we can use the same technique. Like we have to see if I add how many to this negative 12, that will give us this value. If you add 9 to this 12, you will get negative 3. So 9 and 0, that's going to be the decibel. So the decibel is going to be 90 decibel. This will work if you have 1 times 10 to the power minus, like if you have 1 time anything. But if you have like this one, 40 times, if you have a number in front, you cannot do this technique, right? So this is a shortcut you can remember. So whenever you have decibel like 70, 80 or whatever, it's easy to convert. For example, 80 decibel. If you want to convert this one into watts per meter square, just add 8 to this power, and that's going to be the watts per meter square, right? And if you add this one 8 to this one, what's that's going to give you? That will give you 10 to the power minus 4, right? So 10 to the power of minus 4 watts per meter square is going to be this one in terms of watts per meter square. And you can already see this is 10 to the power minus 4 times 2. We convert this one using this formula, but we don't have to even use that. And that's how we can do this kind of problems. I hope you guys find this video helpful. See you next time.